So second example of finding critical values. Again, keep in mind critical values are when the derivative is equal to 0 or undefined, right? Those are the spots when we might have a relative maximum or minimum. And so what I need to do is I need to find my derivative first. So this is set up like a quotient. I have to analyze my structure first. And I don't see a way to make it a non-quotient unless I just wanted to use the product rule, which I don't really want to do that. So let's go ahead and get our derivative. So we're no low and make sure that we have that whole thing times the derivative of the upper, which is 4, minus the upper times the derivative of the lower, which is just 2x, right? That's all going to be over x squared plus 1, the lower function squared. So let's just clean this up a bit. We'd have f prime of x equals, I could distribute that, so we'd have 4x squared plus 4 subtract 8x squared all over x plus 1, x squared plus 1 squared. And then we could simplify this even more to really, 4 minus 4x squared all over x squared plus 1 quantity squared, right? So that's f prime of x. So now I'm interested in when is this thing equal to 0, right? Because when is the derivative equal to 0? Well, if the derivative was going to be 0, that means my numerator would have to be 0, making use of structure. And that really means that x squared would have to be 1, so x could be a positive or negative 1. Ooh. Okay, yeah, that's good. All right. I was worried that was going to create an issue in our original function, but I was missing it, right? Because it doesn't actually. So then next, I'm really concerned, is f prime of x ever undefined? And so that means that really x squared plus 1 squared would be 0, right? The denominator would have to be 0, which really just means that this would have to be 0, which really means that x squared would have to be negative 1. And since we're not doing calculus with imaginary numbers, there's no solutions there, so that don't have to worry about that. And that means for us that these are our only critical values.